There are two major heresies here, gigantic heresies, possibly the largest heresies that we've faced in our lifetime, our brief lifetimes. One is that it is possible to get more energy out than in from an unknown source, whether it's a nuclear reaction or whatever. It's coming from hydrogen materials, which is abundant, which means once it's technologically developed, the complete end of the fossil fuel era, the end of fission, certainly the end of hot fusion, even the end, I would have to say, of other forms of alternative energy, such as solar power, geothermal, wind energy. Those are very fine and good, but they can't even begin to compare with a compact source. The other heresy that is implicit in all this is the ability at normal temperatures to transmute elements. And even skeptics have now found, they wish they hadn't found it in their experiments, they found changes in the heavy metals. They found rhodium and ruthenium and silver. They can't explain this. It is unexplained, but it is, you might say, it's a miracle. And remediating nuclear waste, by the way. That's another prospect that cold fusion has given us. The central dogma, which we all have accepted, I accepted it certainly, you cannot have a nuclear reaction except in a high-energy accelerator, like the kind you build for billions of dollars in Texas, you know, the hole in the ground, 54 miles around, or perhaps in a hot fusion reactor. You know, where you create the conditions of the sun in a reactor on Earth. But what we now find over and over again in cold fusion experiments is that elements are changing. They're transmuting. Along came two chemists in Utah, world-respected chemists, Dr. Stanley Pons and Dr. Martin Fleischmann, on March 23rd, 1989. And they announced, hey, physicists, we have done something in our little cell which you haven't done and don't plan to do until the year 2050. You want $500 million a year to build us a hot fusion reactor in the year 2050 that will have lots of radiation, but it will still use hydrogen from water. Guess what? We can do it now. The physicists didn't like that. Okay, that's why they got so hot under the collar about this, and why anyone today, including myself, who's involved in this field, is not very well respected in the circles of mainline physics. We may be faced, there are two possibilities here. Assuming the data is correct, for the sake of argument, assume the data is correct. I mean, I know it's correct. I was a skeptic myself at one time, for the first year, let's say, and then I increasingly accepted hey, the evidence is shouting at us, it's there. But, okay, for those who don't believe this yet, assume for the moment that it is real. Now, we can go along two possible paths. One, new physics, radically new physics, a crack in physical law somewhere that we didn't understand. We crossed the wrong bridge somewhere, and we have to kind of back up and redefine things. That's one possibility. The other possibility is that we can take quantum mechanics, take relativity, take all we know, and use it like a toolkit. That's what scientists usually do. They take what's known already in theory, and they say, aha, in this new system, we can use those laws in such and such a way, and we can explain it. It seems increasingly likely to me that there is going to be some new physics here. And it may be that what Pons and Fleischmann originally thought they had, and what others today still think they have, namely a marvelous new kind of nuclear reaction, it may not be that at all. It may be something much more profound than that. I'll tell you what it might be. There are theories today of what is called zero-point energy, that is the quantum fluctuations of space. This is accepted, by the way, by physics, that way down at the microscopic level, way below the size even of nuclei and parts of nuclei, there are these fluctuations in space. Several serious theorists have put forth the idea that it might be possible to tap that zero-point energy and thus extract energy from the vacuum. And perhaps that is why we are not seeing the nuclear products in cold fusion that would be commensurate with the heat. That may be the reason. Some people think it is, others think it's not. I know the mentality of the United States. And the mentality of the United States is such that when we finally win the cold fusion war, which we definitely will, okay, we're going to end all fossil fuel usage, period. It has been officially neglected. For example, when candidate Clinton was in this area in 1992, he promised to investigate it. To me, I have it on tape. He told me that he would. He did nothing of the kind, okay? He, through his Department of Energy, increased the hot fusion budget until it was recently cut by the Congress. Secondly, Vice President Gore, as an example, was presented by a senior official at Apple Computer Corporation with the information about cold fusion. He said, don't even give it to me, it's too controversial, get rid of it. And that's what happens over and over again. It all goes back, and this is heavy Watergate. It's not Whitewater, it's not Watergate, it's not Waco or Wacko, it is heavy Watergate. And this scandal, it's amazing that this scandal is continuing. An American invention kicked out of the United States, being now in the hands of Japan. Japan takes it seriously and we don't.